going beyond 5G. I hope that was an interesting session. We're now going to try something new, at least at this event, which is trying to look at a more project-based approach, or taking some of the issues from the research projects. So we're going to start now with a session where we look at cross-regional projects, so projects that are running in more than one geographical area, as in Europe and America, or Japan and China. And this is hopefully an interesting dimension which isn't covered in any of the single regions. And then we are going to look more at the KPIs, so some of the results of the projects or some of the 5G work that's going on. Okay, so let's start with this first session on the cross-regional projects. And I'd like to welcome to the stage Mr. Du from Huawei, who will moderate this session. Thank you, sir.
Good afternoon. Good lunch. Yes. This is my honor to be the moderator of session 5, cross-region projects. My name is Du Yiqing, come from Huawei. So I'm a little bit busy, actually, like my company, right? Okay. Telecom industry have the best tradition of cross-region cooperation. If we look back, the old generation of the technology is the achievement of a cross-region cooperation. Telecom industry, it is the most standardized industry. But in this initial stage, there's still a lot of things needed cross-region cooperation, like the standard, like the user case solution, terminal, and the whole ecosystem. During the 5G's coming, we think more and more industry also will be involved inside of the 5G industry. So I think in the future, the cross-region cooperation have some more new meaning. Today, we have 6 experts come from different countries. Will bring their latest project progress and their viewpoint. Firstly, the first one, we will welcome the Graduate Program Coordinator, Faculty of Computing, Federal University of Uberlândia, Professor Floria de Oliveira Silva. Let's welcome.
Hi, good afternoon, everybody. I hope you can stay awake during my talk after lunch. So I'm Flávio Silva from the Federal University of Uberlândia, Minas Gerais, Brazil. So we're talking here about this cross-regional projects. And, so when I'm talking here, the perspective I'm talking here, when I'm talking about cross-regional, is what Colin said. We're talking about international joint collaboration project between different countries. Because this cross-regional meaning, sometimes in Europe, it means different, even regions in the same country or different countries. So we're talking here about different projects between different countries. Well, obviously, I'm talking about or showcase here some cross-regional projects between Brazil and abroad. Regarding 5G, most of the joint collaboration projects that occurs between Brazil and Europe. So we have a very strong collaboration, Brazil and Europe, research collaboration, and so this also happens in 5G as well. So there is a 5G range project. My colleague Luciano will talk in the next more about it. Project like football, we finished recently. Project like NECOS, which is about networking slicing using cloud computing. And 5G in Fire, which is about networking function virtualization infrastructure. Well, so I would like to present briefly for you guys what we have in our city, Uberlândia, which is a very unique infrastructure that we have there regarding next generation infrastructure, networks, and applications. We participate on this, talking about this cross-regional collaboration on several projects between Brazil and Europe. So Ophelia, Fibre, Fireware, 5G Fire, Nexus that are ongoing, we're all part of this projects or international joint collaboration projects between Brazil and Europe. And so, and also we have in Uberlândia a very nice situation that we have a regional telecom operator that is headquartered in our city. So we have a strong collaboration with them, and we have this connection, physical connection with them. So what we have there is kind of, I would like to showcase these different infrastructures on top of what we have from fiber, from FiWare, 5G and Fire, and also NECOS. And a kind of innovation lab that we talk together with the telecom operator, and it's a very interesting situation because we're there in the academy, but we're also talking with the industry and trying to find out ways to collaborate and ways to go forward and use the technology and develop new situations. So this is a kind of result of all these things that I will present for you, this kind of projects. So let's talk about football. So football project is jointly funded by Brazil and Europe. So there's some agreements between Brazil and Europe. This was selected in open calls. So the idea of this project was to create a federated control framework to integrate different test beds in Brazil and Europe, in bringing together academia, industry, and trying to work especially with optical and wireless broadband, backhaul, and also mobile edge computing. So as you can see here, the partners, whoops. So as you can see, Europe and Brazil, several universities in Brazil. Each UF means by a federal university in Brazil. We're not part of that directly, but the infrastructure that was run also was based in Uberlândia, part of it. So it ended in May 2019. Well, another, oops. So this infrastructure is already available to the community, or I mean to use by the academy, by the industry, by people that are interested in going in this area. So the NECOS is a kind of novel enablers for cloud slicing. Also a joint funded project between Brazil and Europe. And the idea here is to use cloud computing to create what they call a lightweight slice-defined cloud computing. So the idea is to forward or to seek the multi-domain slice provision, for telco, so you can experiment different scenarios using cloud. So here, as you can see, different partners from Europe and also from Brazil. We are all part of that as well. So it's an ongoing cross-regional project. It will end by October 2019. Usually this infrastructure remains and stays for the use for new developments. And by the way, I would like to present 5G and Fire, which is funded by Horizon 2020 and also by the Brazilian institution. It's a kind of different things here. So it's a kind of the institutions funding these projects. So the goals here of the 5G and Fire project is to establish our NFV-enabled experimental infrastructure. So the idea is to support different vertical industries and create a place where different actors of this 5G ecosystem, I mean startups, industry, SDOs, operators, academia, where they can experimentally contribute to the 5G development and deployment. So the idea here is to use an open source management and orchestration infrastructure, which is based on industry standards. So we're getting what is being used in the market, and to create different network slices here based on the requirements of each vertical, and also integrate with previous test beds, which were based on the future internet research and experimentation for it as well. So that's what we're doing 5G and Fire. And the partners are from Europe and Brazil. Well, so just to point out, this is what we have. This is the main test bed. So the idea is we have like a management and orchestration entity in the core, which stays in 5 Tonic in Spain. And then we have several test beds around Europe. And these test beds, and also one in Brazil, and these test beds, they focus on different verticals. So we have a hardware, we have particular, like a mobile edge computing. So the idea is kind of to show like a mobile operator with its core in mobile edge computing in different areas or different verticals. So right now, there is the automotive test bed in Aveiro, Portugal. The e-health is in Poznan. And then we have the 5G media from TNO. Also the public safety, guys from Internet Institute in Ibuhana. And also we have the smart city in Bristol and also in Brazil. So these are the verticals we are exploring. By the way, just to remind you, there is an open call open for this. So the idea is to bring innovative experiments to the ecosystem. So most of these projects also give opportunity to others to come and to bring new ideas and to develop and to give opportunity to talk of what we are doing. It's a kind of development of 5G that is already ongoing. So things are not ready already. So what we're talking here about all these infrastructures is a kind of 5G testing. So to make tests, so 5G is under design, it's not ready. Although we're talking about the previous section about what's beyond, but we are still on that track also. So with these infrastructures, we can test some aspects of 5G, like different radios, different kind of frequencies. This is all possible with all this test bed. So the 5G for our focus is about NFV, so using an open standard design manual. So the idea is that this environment is always open and to different actors, and in fact is that it creates a very interesting flow between Brazil, Europe. We're talking about this. So industry, startups, STO operators, academia, research institutes, that's what we are talking here about. So about 5G in fire, so the idea is to test new VNFs, new services, new architectures, which is most of the 4C for the network architecture of 5G. So just to conclude, 5G research, standardization, development, and deployment is a joint international effort. For sure, if we're working together separately, we could need to, buy smartphones when you travel in the airports. That's what we not have. We would like to talk, seamless around the world. So it's a joint international effort. And these cross-regional projects, I think it's a tremendous opportunity to foster these efforts. Because when we're talking about these cross-regional projects, we are enhancing the international collaboration between different actors. So we're putting together government, industry, academia, we're all together. And also, it helps to create like a global common view of ICT, focusing different use cases on different markets in different places. So as long as we are all together, we can have better solutions. And so these solutions, we can say that provided by 5G, they can be deployed locally on the specific use cases, but also they can solve problems globally. So the opportunity here that it's to benefit a broad of our society as a whole in a global way. So this part of this effort as a whole. So it brings really valuable results when we're all together, when we're working together, and I think that the solutions that comes and that arise, they're better. Well, that's so. Thanks for the opportunity. And last but not least, I would like to invite you guys to be in São Paulo. We're going to have an IEEE 5G São Paulo Summit. You'll be doing FutureCon. If you guys have the opportunity, let's come to Brazil and keep this discussion about 5G. Thank you all.
Thanks, Professor Silva. Very impressive name, 5G in fire. Several weeks ago, I just been in Brazil to join the Terry Brazil Summit. So it seems that it's a very high possibility that the spectrum auction 5G spectrum auction will be starting very early of next year. So I think the 5G in Brazil will be very soon in fire. Okay. Second, the next speaker, it is come from the coordinator of research committee at the 5G Brazil project and the research coordinator, Radio Communication Reference Center at Inatel, Professor Luciano Leonel Mendes. Please welcome.
So good afternoon, everybody. Thank you very much for attending this presentation. I will talk a little bit about the 5G range, which is a project between Brazil and Europe. And we are trying to close the gap that you have in connectivity in remote areas. So our main goal here is to try to provide a reliable and a good internet connection in remote areas. I'll try to explain a little bit what is the motivations and applications behind this idea and why it's so important for countries like Brazil, but not only for Brazil, but also for other countries that have continental size. We can see that there are a lot of new applications that can be applied in remote areas. You have a space for voice and data connectivity, where you have people that is not connected and are willing to be connected in the network. Also, you can open new markets for operators. Actually, you can open the opportunities for new players in this market. IoT in remote areas is one of the most interesting applications where you're going to deep in a little bit, as smart farming as an example. Hold coverage in the remote healthcare are other applications also that are very important. So I'd like to address a little comments regarding these motivations. So regarding voice and data connectivity, that's the last frontier for us to have a really universal internet access. Right now, when you are in the city, everybody's connected, but you just need to leave like 5 kilometers or 6 kilometers, then connection drops, and you are really in the dark. And there are 3.9 billion people, according to ITU, that are not connected today. A big part of this number is because people are living in an area where the service is so bad that they're not willing to pay for that, or they are completely uncovered. So I think it's time for us to change this reality and really provide a solution where people can choose to be connected if they want to. And that has a very high social impact, right? We can start saying about education, right? You can imagine that children growing up today without internet access, without knowing what YouTube is, or without knowledge about WhatsApp or how to communicate digitally. What kind of future a kid like that will have? So that's the question that we need to start thinking. Also, entertainment, it's very important, right? We have a lot of opportunities to entertain ourselves in the cities, but in remote areas, people are really segregated from this digital world. Also communications and digital integration. So those are very important issues that I think we need to address that in the 5G area, right? Not beyond 5G or not in 6G. For the operators, we can see that there is a huge market behind these remote areas applications. One example is regarding the smart farming, right? So the production improvement in the farms, it's always a demand. So Brazil, as a huge food producer, is always suffering pressure to improve production of agribusiness. And that has a huge impact on nature, on the environment. Because usually, to improve the production, you need to increase the area that is exploited. So we do believe that technology can increase the productivity in these areas. So the same square kilometers of a farm can produce much more than you have today if you have the information from the field. So that comes to the smart farm application, where the idea is to collect data from the soil, from the air, from the water, and provide the needs of the farm so the productivity can increase without demanding a larger area. Also, you can increase productivity by using machinery that are connected, so automated machinery. An idea of the automated car, but for machinery doing the platooning for harvesting and also seeding the farms. One note here regarding the smart farm is also about the security of the employers. So on the left side here of this picture, we can see how you deploy the pesticides today. So you can use planes where they fly very high and deploy a cloud of pesticide on the fields, and that cloud also goes to the other places and cause a lot of health problems in people that live outside the farms. Or in the case of the picture on the left side below, there is this tank full of chemicals where people put that on the back and start spraying that on the trees. So of course they are exposed to a very large amount of chemicals, which is not very good. But if you have a reliable network in remote areas, you can use drones for doing this deployment. So first of all, there is no person in contact with the chemicals. And the second one, the drones can fly very low, close to the crops, and deploy exactly the amount of pesticide that's needed to guarantee a good production. So that's very healthy and more safe in terms of environment. And of course, we do have the demand for road coverage. Everybody would like to be entertained in a car when you are driving, with music nowadays, with Spotify and this kind of streaming. But once the cars get automated, even though they don't need the network to stay on the track, they can do that by itself. What you're going to be doing inside of the car, right? So connection will be really important in roads. Not only for entertainment, but also for the V2X connection. Vehicle to communications with the infrastructure, vehicle to communication with the other cars. So this connectivity is very important also, and it needs to be supplied everywhere. Mainly if activity safety starts to play a role in the future vehicles. And last point here is about remote healthcare. It's very important for remote areas also. Those people do not have access to specialized treatments because they cannot get in touch with the doctors. So you can use that for conference calls where the patients can go to a center and get connected to the doctor that are in a big city and get good advice about how to do the treatment. But also we can connect devices that can get blood samples or do some testing locally and send this information to the medical center in the big city. So remotely we can do some sort of sorting and detect what kind of patient are in a bad shape or not so bad shape and try to provide the best help for them. So information here is really important for a good care. So how 5G range is trying to do that? What are our goals and how we are trying to address those issues? How we think that's possible to provide this network? So the goal is basically to provide a mobile, reliable, broadband connection in remote areas. We'd like to overcome the two biggest problems that you have today in terms of deploying networks in remote areas. One is the cost of this network, and the second one is how reliable this network is. So how much can we trust in this network? So our basic idea is to overcome the problems that we have today with 4G and the current 5G standard, the new radio. Basically what you are moving to, if you look to the enhanced mobile broadband, the ultra reliable low latency communications, or the massive machine type communication, it's pushing us to have a smaller cell. So we are talking about small cells, very dense cells, and to provide a good connection in remote areas, you need to go to the opposite way. You need to go to a larger cell, right? So you need to increase the coverage in order to have enough subscribers within a cell so they can actually pay a reasonable amount of money for the service. So that's the goals that we're trying to do. And there are two main technologies behind it. So you need to change the physical layer and the MAC layer to provide this connectivity, the robustness of this connectivity, and also using TV white space in a secondary way, as a secondary users. So those are the two key points that is sustain the 5G range network. So in terms of requirements, what we're trying to achieve is to provide the 50-kilometer radius for the cell, and at the cell edge, we want to provide 100 megabits per second as peak data rate. Mobility, we are aiming to support up to 120 kilometers per hour, and two kinds of services must be provided. The first one is mobile broadband and also IoT connections. So what are the features that will support this? Robustness. We are using MIMO for diversity. We always talk about MIMO for multiplexing to increase data rate, but we'd like to use MIMO to provide more robustness. So provide diversity for the users, mainly for those that are far away from the base station. For those that are close to the base station, they can use the antennas to provide the higher data rate. So multiplex is also possible, but only when you have a very nice SNR. If you are far away from the base station, then you use diversity to provide a reliable connection. And also using polar code both for the control channel and for the data plane. So we do believe that polar codes can be used to increase the robustness of the system. In terms of smartness, you need to be aware of the spectrum availability in remote areas. So you do sensing and also using geolocation database to make sure that we know what are the opportunities to be used in UHF bands. For doing that, you need to provide a very flexible physical layer where we can change the frequency that you're using according to the availability of the spectrum. So for that, you needed to have a very low out-of-band emission waveform, because you cannot use RF filtering in this case. So the idea is have a very low out-of-band emission to allow us to change the channel without the need of RF filtering. And of course, as you're talking about 5G systems, you need to be flexible to cover several different applications. So you need to change the parameters on the fly, need to be very flexible, and you need to evolve. So that's why we do believe that software-defined radio and Cloud Run can be applied quite well in the system. So this is the basic block diagram of what you're proposing. So the blue blocks are what you are promoting and they are created and implemented here. So you're using a very advanced coding scheme, which we call here ACRA. We are innovating also on the MIMO area by creating this diversity/multiplexing scheme with a new waveform, which we call Flex Now. And you are providing this together in a frame that's flexible to cover different applications. On the MAC layer, you are adding new blocks that allows the network to exploit this TV white space. So you need to do the sensing, you need to do the dynamic spectral location, and also fragmented spectral location. In terms of implementation, we have built this system already. The physical layer is ready, it's running. You are exposing this system here at EuCNC. EuCNC thinks that it's beyond 5G, so that's why you are at the end of the hall in the beyond 5G section. You can find our booth there, where you can actually see this system running in real time in there. And basically that's the block diagram that we have implemented, which is running there in real time. It can provide high throughput, more than 100 megabits per second, and it uses up to 24 megahertz of bandwidth. So you took this transceiver and you install it in a car, and you start doing measurements already in terms of coverage, throughput, delay, latency, and so on. So you have been using 2 UHF channels in Brazil. You can use 1 or 2. So in Brazil, you use 6 megahertz channel. The overall goal of the 5G range is to use up to 24 megahertz. So it's scalable. You can use 6, 12, 18, or 24 in Brazil. And you're using here more or less 50 dBm as the transmit power. So here it's the largest distance that you could achieve in your test. It's 50.6 kilometers away from the base station, right? So you can see that's a very really environment, although at this point you have line of sight between the receiver, the mobile unit and the base station. And with this approach here, using 12 megahertz, we achieved the 57 megabits per second. So that is the throughput that you could provide at 50-kilometer distance using this physical layer. So if you double the bandwidth, go from 12 to 24, and keep the same power spectral density, we would be able to achieve 114 megabits per second, which is a little bit above what you have proposed initially. And we also did a demonstration about what kind of impact can this technology provide in the real world. So we took this transceiver and put that in a very small school in a rural area in Brazil, where kids had no access to internet at all, did not ever saw a web page in a computer. So we assembled there a lab, a computer lab, where the kids could start interacting with the internet for the first time. And also we did a very small, very simple IoT kind of application where we implemented 3 gardens, smart garden as we call it. So it's 3 gardens with 3 different kinds of plants that were being cultivated in these gardens. Each plant demands a different amount of water. So the kids could see in a dashboard how much water, humidity we have in each soil of each plant, and they could start or stop the watering system remotely via internet. And also have a camera recording the garden all the time, make sure that there is no rabbit eating the lettuce that they are producing. And with this, you could stimulate the kids to go more into technology and also demonstrate that remote area IoT is actually possible using this technology. So what are the conclusions and what are the next steps of this project? So the main conclusion is that 5G is ready to close this gap. So technology is there. And the technology that you're using is actually the same technology that is being provided for 5G new radio. All we have been doing there is tailoring the numbers, the parameters, to supply this network in remote areas, to support this network in remote areas. So we're not talking about really any different technology here. It's more about tailoring the technology for this application. And with that, we can provide a really universal internet access where everybody can be connected. So technology is ready for this achievement. Standardization is a challenge, right? So going to the standardization procedure, it's always a huge task. But in this case, you're not promoting any technology, right? What's important for us is to have a 5G mode that can address the remote area application. So what you are promoting is actually the motivations, the applications that should be covered by 5G somehow, right? 5G range has a solution for that, a technical solution, but other solutions can also be available. The more important is to have this question addressed. So I think we need to increase a little bit the discussions around this topic. You have been evolving on this, it's growing up, but I think it's time for us to start talking seriously about it. So that's the main conclusion. The next step is actually to do this standardization procedure. So that's what we are trying to pursue now. You have the demo, you know that technology works, it can solve problems. Why not have an official 5G mode for that? So thank you very much for your attention.
Very impressive, very detailed and practical project. So same to Brazil, actually China also a very big country and also have a lot of the same unbalance in education, healthcare. Yeah, so that's why in China we also have a lot of such kind of 5G use case for remote healthcare, remote education also. So I think this cross region also could be include the China market, and I think we can build this connection later. Okay, so next speak is come from EuCNC 5G, Mr. Uwe Herzog. Please welcome.
So good afternoon, ladies and gentlemen. My name is Uwe Herzog. I'm with the company EuCNC. We are located in Heidelberg in Germany. And I'm the coordinator of the 5G Drive project, and I have the pleasure of giving you some information about this project. The title is 5G Harmonized Research and Trial for Service Evolution between EU and China. And as the title indicates, and as you probably will have also expected from a presentation in this session, we are not on our own, but we have another project, a twin project in China, which is working together with us towards the same objectives. We actually have another presentation on the same cooperation in this session. So this will be given from the coordinator of the Chinese Twin Project. Therefore, I will focus in the presentation on the activities that are being done in 5G Drive in order to prepare for the joint trialing activities, but also in order to give you some first results that we have already achieved and also inform you what the status of activities are. Okay, maybe let's start with a brief overview of 5G Drive. So our goal is to bridge the current 5G developments between EU and China, and we want to do that through joint trialing activities, but also through some research activities in order to facilitate the convergence of technology, but also to harmonize spectrum and promote business uptake. If you look at the chart at the bottom left side, you get a very good overview of the main aspects that we have in our cooperation. So you see the two consortium. I think this is important to point out again that we have on the one side a 5G Drive consortium, and on the other side in China, the 5G large-scale trial consortium. These are two independent projects just with the same objectives and the interest to work together towards these joint objectives. What you see here is basically also what we had when we prepared the project proposal, and to give you some also organizational background of how this works. So this is basically what we had, joint trialing, technical innovation, and then also using EMBB and V2X as the main use cases. And this is what we had when we started preparing the proposal. So therefore, we had a quite good and detailed plan on what we wanted to do in our project in 5G Drive in order to achieve that. But we hadn't really discussed with the Chinese side on how we're going to realize this joint trialing. And this is what we actually only started when we launched the project, when we kicked off the projects. And for every one of you who also attended the previous Global 5G event in Rio de Janeiro, where I also gave a short presentation, and this was only 2 months after the start of the project. There was also a question about the details of the joint trialing, and at that time I could not really say a lot because we had just started and we hadn't really discussed with the other project. We had only 2 weeks earlier a kickoff meeting where we had first discussion on that. But today we are a few months after that, and we have progressed quite well, and I'm happy that I can give you now some details on what we have planned so far. I will focus on the presentation on these joint collaboration and trialing aspects, although I have also prepared quite a few slides on the technical details of what we plan to do, but I think I flip rather quickly through those to make sure I have enough time left for informing you of the joint collaboration things which come in the second part of the presentation. The project itself is a 2.5 years project, and we are a European Commission funded project, Horizon 2020, and we are part of the 5G PPP. And we have 17 partners, and you can see the logos of the partners. We have a good mixture of industry, SME, and also academic partners to address all the competences that we need in order to do the trialing on EMBB and V2X. What you might miss here in the list of partners are telecom equipment manufacturer, but 2 of the trial sites in Europe have very close link and cooperation with manufacturer, through which we make sure that we have all the required equipment available that we need in order to do our trialing. The joint trialing that we plan to do will cover the full spectrum from terminals over radio access network, core to the service level. And EMBB and cellular V2X are the use cases that we are going to use for the trialing. And within the bubbles on the right-hand side, you can see the trial sites. In blue are the 3 trial sites that we have in Europe, and in red are the 5 sites that we have in China. I don't need to speak a lot about the project plan because it's not much different from other project plans. We have some definition phase at the beginning, and then we structure the actual trialing into 2 phases. So let's quickly move to the next slide. So, okay, let's briefly go into what we do in 5G Drive in order to prepare for the joint trialing on EMBB. We have 2 trial sites in Europe for that. The first one is in the 5G IC in the University of Surrey in the UK. You can see on the left-hand side with quite some impressive parameters in terms of size and also number of sites and cells. You can get further information there on the frequency, and nearly as big is the trial site that we have in Espoo in Finland, with a number of functionality that you can see there. The progress up to date at a glance. I will go into more details later on. So the setup of the test beds in the different sites is in good progress. Actually, in the Surrey trial site, we have already started with some first trials on EMBB. In Espoo, we expect the installation of 5G equipment after summer. We have defined the test plans, and by the end of this month, we expect that also the joint test specification for the joint trialing between EU and China will be ready. These are some pictures and some charts that give you some more details on both trial sites. So the one in Surrey, on the 5G IC, you can see a photo of G-Node B and also some components of the radio access network. And I've put there some more details on some features of this. At the bottom, you can see our prototypical UI, which is based on open air interface. Actually, we didn't want to rely on commercial 5G equipment becoming available, and therefore we have prepared everything ourselves. The form factor is, of course, not that nice, but for doing measurements, it might be even more suitable because we have full access to all data and all the information, and can fine-tune according to what we want to measure. Similar on the right-hand side, you get some chart, not sure how readable that is, for the Espoo trial site, the radio access network. And at the bottom, you can see a tool that, a snapshot of a tool that has been prepared in order to do later QoS and latency measurements. And finally, on the indoor coverage measurements, which have been prepared in Espoo as well, where some mobile robot is being used in order to measure the coverage indoor, and jointly with that also test several different positioning technologies. So this is some background on EMBB, and then on V2X in Europe, we have also 2 trial sites. One of those is in ISPA at the JRC, where they have a large area of road and under real driving conditions. Then they also have quite a few emission laboratories and quite impressive features. So we have very good conditions at this site. And then again in Espoo, they also have the trial site for V2X. And on the photos you can see an aerial view of how it looks. Also for V2X, at a glance, the current status. So the trial plans have been defined in ESPO and ISPRA as well. We have frequency that are available for use for the trialing, and in ESPO also a first V2X trial has already been done in the middle of the last month. And the trial cases that we are going to use is green light optimal speed advisory use case and intelligent intersection. Okay, then a few words about the JRC test site. The JRC test site will mainly be used in order to compare and check the usage of ITS-G5 and LTE V2X and compare them. So there is basically a three-step approach. First, in the lab, some evaluation will be done, whether ITS-G5 and LTE V2X devices are conformant according to the standards. Then we will exploit the availability of the anechoic chambers that we have in ISPA in order to do some over-the-air transmission and measure whether there is any harmful interference between both technologies, which is in particular important for Europe, as both technologies are there, and as you might know, on the political level, ITS-G5 is to a certain extent favored at the moment, while there are also good number of industry players who are actually favoring LTE V2X. So therefore it's important to see how both could work together in the same area, in the same frequency band. And finally, some outdoor field tests will be done. And this is just to show some pictures of the roadside unit and also how the anechoic chamber look like. Okay, and then also 2 slides quickly on the V2X trial equipment in ESPO. There we also build on the availability of an autonomous driving car, where we will fit into also the V2X equipment. So we have joint usage of both aspects. Some information on the infrastructure, how it looks, and also on the planned route that will be used for the trialing. Okay, and then these 2 use cases. Okay, and then some information about the joint trialing between EU and China. So first of all, that's the set of KPIs and for the various scenarios that we have selected that we will look at and focus on both sides. So it's for outdoor, indoor, and then also on application level. That's for EMBB. Then for EMBB, we already have made quite good progress on planning what we want to do. And basically it's a 2-stage approach. In the first phase, we will do basically joint tests and measurements on the network infrastructure, let's say like that. And in the second phase, we want to do a joint test on application level. In this first part, we have already done good coordination with the Chinese Twin project in terms of what tests we want to do, and also that we can gather comparable results and then to enable us to compare them, so having something that we can seriously compare. Still, some calibration might be necessary. And the first tests that are planned from mid of last month until early July will basically focus on performance measurements, some indoor coverage, and also MIMO performance trial aspects. Okay, and then, as I said, second phase with a joint application layer trial between the 2 regions that we have in mind. These are some photos from the trials that have been done recently in China between both teams. This is in Hangzhou. And these took place in the last week of May, where some basic performance tests were done. And this is just to give you some idea of what results have been achieved and what has been measured. So we are using a non-standalone architecture for that. And basically the tests were made by going with a vehicle in low mobility, less than 30 kilometers an hour, through the streets where 5G coverage had been deployed. And you can see the KPIs that we have looked at, and also some information here on what data rates we have achieved. So for downlink, peak rate achieved was 1.2 gig, but on average it really depended on basically whether there was line of sight or not. So as you can imagine, between 400 and 900 megabits. And for the uplink, it was between 30 and 100 megabits. Okay, and then this is just a first rough idea on the plan for the joint AR/VR application across the two regions. So this will then be on the standalone with also 5G core and including slicing everything, and then connected between the two regions. And if this will be successful, then I think it might be the first joint trial between, on 5G between EU and China. Okay, and then on V2X, joint trial topics. So this is the proposal on what we are planning to do on use case level. So green light optimal speed advisory. Informs the driver what speed needs to be maintained in order to have green light at the next traffic light, and then also the intelligent intersection, which basically aims at improving the safety of all people and participants around intersections. This is also, again, only a first idea, a proposal for how we could implement the joint trial on V2X. Maybe important to mention is that we consider that we'll have V2V. You can see that here. Can you see that? Not really, okay. With PC5 standard, then also PC5 for the side link, vehicle to infrastructure, but also to use the UU for LTE to connect to the network, vehicle to network, and then we have the cloud server in the back where all the data and logic is and decisions are being made. And this should then work, of course, with the onboard units and roadside units according to the modes that are being used in Europe and also in China, which are slightly different. Okay, and this is some final thoughts, some initial idea, and this is not fully clear to us yet whether we could do it in the end actually. But we have in mind to do some V2X tests from Espoo to Shanghai, where one of our partners is interested to provide a car which they already own and equip it accordingly, with which we can make tests first in Finland and then go with the car to the trial site in China and then repeat the same test there to really show interoperability. Okay, we have other work items ongoing, but I'll not touch upon that given that my time is up. As I mentioned, we work on several research topics as well, and also will address some regulatory aspects, which in particular the JRC is interested to work on, but maybe we have more time at a future presentation to go into that. And that's all from my side. Thank you very much.
Thanks, Mr. Hazor. So I think maybe next year when the 5G event held in Shanghai, you can introduce your cooperation with Shanghai. Okay. So next speak is come from the Domain Support Manager in Future Mobile Communication Research Division in ETRI, Dr. EuCNC. Let's welcome.
Thank you, Chairman. Hello, everyone. I'm Il Kim from ETRI in Korea. ETRI is the government research institute in Korea. Today, I will introduce two projects, 5 Champion and 5 All-Star. The left side is the logo of each project, respectively. 5 Champion project was already done, but the 5G All-Star is currently underway. These are the contents of my presentation. I will mainly present the result of 5G Champion project and then briefly introduce the new 5G All-Star project. The full aim of 5G Champion was 5G communication with the heterogeneous H3 mobile network in the Pyeongchang Winter Olympic competition. And the coordinator of Korea was Dr. Hyung-Gyu Chung from ETRI, and the coordinator from EU was the Emilio Calvanese from CRT. There were 12 organizations in the Korean side, including 2 cellular operators, SK Telecom and KT, and there were 8 companies in European side. And the total period of the project was 2 years, and it ended May last year. This is the picture of the kickoff meeting. He is the European coordinator, Emilio. And this person is the Korean coordinator, Dr. Hyung-Gyu Chung, and I'm here. The goal of the project was developing the first 5G POC system in the conjunction with the 2018 Winter Olympic Games. And the POC system was being focused on the millimeter radio transmission technologies. There are 7 work packages. The work package 1 for the project management, and 2 for system architecture, use case and requirement, and millimeter wave technology was studied in workplace 3, and core network and cellular life for workplace 5, and integration of 5 Champion POC and Olympic demonstration was dealt with in the workplace 6. And finally, workplace 7 took the dissemination and standardization. I was the workplace 6 leader in this project. This slide shows the millimeter wave PO system. The left side is Korean millimeter wave PO system, and the right side was the European side PO systems. 2 systems use the similar technologies. For example, WebDM-based technologies. But the frequency was different. The blue part used for the Korean POC, and the yellow part was used for the European POC. And red part was used for the Korea Telecom's 5G service in Pyeongchang areas at Olympic period. We use different frequencies in order to avoid the mutual interference. And Korean POC was used for the outdoor demonstration in the Olympic areas, but European POC was used for the indoor demonstration in Olympic venues. This slide shows the concept of mobile core interoperabilities. There were 2 objectives in the mobile core interoperability. The first one is service interoperabilities, and second one is management interoperabilities. In the project, we demonstrated those 2 types of interoperabilities based on the intercontinental interconnection between Finland Oulu University and Korea. The final goal of the project was to demonstrate the system, the developed system on the Olympic areas. There are two clusters, mountain clusters and coastal clusters. Outdoor Olympic games such as ski jump and bobsleigh and cross country were held on mountain cluster. But the indoor sports games such as figure skating and speed skating, ice hockey, held on the coastal areas at the time. We made the 5G champion booth on the IT scale located on the coastal areas. In this project, I think the most difficult work was to preparing the demonstration of the developed system on the Olympic venues, because there are many restrictions to use on the Olympic venues. So we have to persuade several times the Korean government and local Gangwon province as well as Olympic committees. So we also had to get the frequency for the Korean POC as well as the European POC. So it took almost 1 year to get the final confirmation to use the 5 champion booth in Olympic venues. This is the blueprint of the 5 champion booth, and this one is the real picture of the 5 champion booth. European millimeter wave POC and Korean 5G core system was installed in the booth, and TV plus VR, AR device and camera was installed in the booth. In the booth, we provided intercontinental interoperability services. We installed the 360-degree camera on the both on the 5 champion booth as well as in the Finland Oulu University. And then we provided the mutual video streaming services. And we could control the camera in the Oulu University remotely in the booth, and the camera in the booth could be controlled in the Oulu University at the time. In addition to that service, we provided interactive AI services with map of the Olympic areas. And these services were provided for the ordinary visitors during the full Olympic period and Paralympic periods. And these services got a good reputation from the visitors at the time. And Finland Prime Minister visited the champion booth at the time. This is the pictures. We also provided the outdoor demonstration in the Pyeongchang areas. 3D multi-view services based on the millimeter wave moving wireless backhaul was provided nearby IT scale places. This is the millimeter wave base station located on the top. We used the SK Telecom's site at the time. And this is the 3D TVs to display the 3D multi-views. In order to support the 3D multi-view service, the data rate of the backhaul link had to several gigabps levels. We support up to 5 gigabps data rate at the time using the millimeter wave backhaul. This is the mascot is the Olympics and Paralympic mascot. This is the ice scale. This is the web champion booth. Mobile phone. And this is a European central. Finland Prime Minister visited 5 champion booths at the time. This is the 5 champion demo board. And this is the millimeter table mobile station. That is the prototype. This is the street for demo. Olympic venues. This is the rim table antenna. And this one is for 3D multiple service. Finally, I will introduce briefly the new project. The name of the project is 5 All Stars, and I'm the coordinator of this project in Korean side, but the European side, the coordinator same, MLOs. And there are 5 organizations, both in Korean and European side. And in this project, there are cellular operator as well as satellite operator in Korean side. The period is 3 years. And this is the features of this project. But I'm not here. The main basic point of the 5 All-Star project is not only to provide the intercontinental interconnection, but also to provide vertical interoperability between satellite and satellite. So until now, we have studied several items. For example, interference management or cancellation or avoidance between cellular and cellular when the two systems use the same frequencies. And another one is the load balancing algorithm between cellular and satellite. Anyway, at the end of this project, we will demonstrate this system in conjunction with the France Open tennis game in, I don't know the location. Anyway, we will provide the demonstration. Okay. This is the end of my presentation. Thank you.
Thanks, Dr. Kim. So I think such kind of very impressive project, it is one of the reasons that the success of current Korea 5G market. Okay, so next speak is from the Deputy Division Director, National Science Foundation from USA, Dr. Tayaga Nandar Gopal.
Please welcome.
All right, before we get started, how many of you, I want to show of hands, folks from Finland, raise your hands. Anyone from Finland? Okay, a few hands here. Folks from France? Okay, and Italy? All right, cool, all right. So I just wanted to call out some of our partners who we have engaged with in the past, countries, not necessarily individual researchers, but again, since we are talking about the theme of cross-regional projects, before we get started, I just wanted to highlight some of the principles. So unlike many of the other partners here, the EU has had specific projects with. We do not have this kind of large Horizon 2020 style big projects and engagements with the United States. And I wanted to kind of, it might seem odd to folks saying, oh, why doesn't the EU have a project with the US? Seems crazy not to. And I just say there are some principles behind any partnership that we want to keep to. And one of the things that, why do we need to partner with something? Wireless is inherently local, right? In all of these projects, if you see this, no matter where you do, you're not going to have a single wireless network cover 2 different continents. It's going to be local. It's going to be in your own country. So why have cross-regional projects? Well, the main reason why you want to have cross-regional projects is you want to have the knowledge, the know-how that one country does not have, that the other country may have. It may be hardware, it may be software, it may be personal, it could be some assets that are resource-specific locations and resources that the country may not have, that they want to see value in partnering with somebody and bring this thing in. Because whether you like it or not, collaborating with multiple people is hard. There is a lot of overhead involved in this constant phone calls, trying to understand each other's language and so forth. So it's not easy to do so. And therefore, you want to do it only when you really, really have a need for it, right? And there is a challenge that you are trying to face. And one of the benefits with many of these cross-regional projects, which I can see, is that it has led to interesting collaborations come out as a result and interesting demonstrations of technology that have come out. In the US, we have done this in a slightly different fashion. Instead of taking one showcase project and trying to highlight it, what we rather try to do is let industries and universities do these kind of partnerships in a very distributed fashion. So unlike many of the 5G efforts around the world, they have a slightly different structure because there's a central entity, whether in the EU, maybe the Horizon 2020 project, in China it could be a Ministry of Science. So within the US, we don't have one entity that is pushing on 5G. Industry does its own thing. We at the National Science Foundation, we fund the basic research, actually in many cases, many years before industry is actually looking at 5G. So we pursue the basic research part, and therefore we just let the natural partnerships form. For example, many of the early deployments for 5G that our cellular carriers have done have been done in conjunction with many of the multinational companies that are across multiple regions, so Samsung or Ericsson or Nokia or Huawei or ZTE for that matter, right? So they have been engaged with those partnerships for a long time. And similarly, many of our researchers that we fund also have been working with folks in other countries. One notable example that I wanted to highlight was this program called Wireless Innovation Cooperation between Finland and the US. It's called the Wi-Fi Us program. So this was a very long-standing program that started back in around 2014 timeframe and went on for about a good 4 years or so. We funded a lot of research in spectrum sharing and heterogeneous networks and IoT network deployments, not necessarily 5G. And the reason why, another reason why we don't want to call it 5G is the NSF views 5G as a very industry-specific term. It's again, 5G is a cellular carrier term. It's not necessarily all of wireless. It doesn't include Wi-Fi, it doesn't include LoRa, it doesn't include many of these other types of networks that we normally use on a regular basis, and we try not to engage in a very industry-specific context. So what I want to talk about here really briefly is the kind of tech things that engage or create these opportunities for partnerships. So one common thread that I've seen, and again, comes as no surprise, is that pretty much all these efforts of partnerships are built around a demonstration project or a test bed, right? So with that in mind, NSF also has a similar thing. So we have so in fact, there's a workshop going on right now about a project called Empower, which is funded by the EU. And similarly, funded on the other side in the US, it's funded by the Platforms for Advanced Wireless Research, PAWR, P-A-W-R. So this project seeks to support up to 4 city-scale large platforms that advance wireless research, not just 5G, but looking beyond 5G, right? The idea was that wireless and is not something that's defined by a generational thing. It's not 5G doesn't happen tomorrow, or it didn't start in 2018. It's an ongoing evolution that will continue to evolve as time goes on. Therefore, we want to look at advanced wireless as a whole, not necessarily based on industry definition of what a standard is supposed to be. So with that in mind, most of these infrastructure components are built to adapt and evolve as time goes on. They are built on extremely flexible SDR and backhaul substrates, and you know, the idea is to accommodate any frequency, any kind of network model, any kind of LTE, 4G, 5G, Wi-Fi substrates that you want to test with, and kind of give, or anything new that somebody might want to come up with, right? Nothing that's industry specific, standard specific, because sometimes new changes come when people least expect them to come from, right? So that's the idea behind this. And of course, clearly we're not saying that whatever others are doing does not have its value. This is our vision of how we see research come. Again, NSF is trying to be ahead of what industry is trying to think of, mainly because industry is going to be really good at what they are investing in. They're going to throw a lot of money in making sure 5G works well. And it's not our job, when you're looking at basic research, to kind of duplicate that effort, right? They are going to be amazing at it. We'll let them do what they have to do. We are looking beyond that, and kind of solve some of the very foundational hard problems so that industry can then build on them. So that's the goal of this project. And with that in mind, the EU, we are partnering with the EU on the Empower project, mainly because we see common principles, right? And these are the common principles that are shared across all of those, right? We want to see these test beds be used to be able to reproduce and provide high scientific reliability and accuracy in terms of the studies that are taken. Most often than not, we rely on data that is supported without any evidence of how do we replicate this experiment and make sure it works for us. How do you trust the author, right, or the institution that's making the claims? We want this test beds and any kind of collaboration to provide that ability to reproduce experiments, right, and hold ourselves to a higher scientific standard than we have right now. We want any collaborative effect to help with interoperability, right? We don't want things to be something that only one entity can do. We want these to be well-defined interactions that can carry results and outcomes and people across the different platforms. We want this to be open access. So I'm using our platforms as an example. These are designed to be remotely accessible, open platforms that anyone can access, including folks from across the world. And we want those similar principles in our partnerships. So in fact, the Empower project is having this workshop precisely to explore the kind of opportunities that we can have to federate and orchestrate experiments across these platforms. So you are welcome to join us in the next round of discussions that's happening in room 6 after this session. The same thing with usability, right? So most of us, when we talk about 5G, we have extremely well-trained network engineers who know how this system works, who know how to optimize it. Something goes wrong, you go to them. But with these kinds of platforms, one of the biggest challenges that we face is that there is a huge amount of technical knowledge that a new student has to come up, has to learn before they can start using. And we want to avoid that, and we want to create a low barrier of entry where you can start off with some basic experiments that anybody can run based on some common experiment setup that the facilities are providing, and then graduate slowly to tweaking individual layers, or start to coding at the application level, or all the way down to the file. So we want to provide that level of usability and also programmability at different levels, right? And lastly, we are not looking at just one, again, this is just, again, NSF's preference. We are not looking at one specific narrow vertical, because we believe, again, that's a domain that industry is going to excel. If the industry feels the need that as a certain value in using network connectivity for a certain use case, they have traditionally excelled in developing it. So we want to keep an open, broad range of verticals that are possible on a platform. So many of these designs are instrumented with that goal in mind. Okay. So again, this is a partnership with many companies. More folks will probably know most of these companies on this. You probably are working with many of them as well in your individual partnerships. It's kind of, we see this as the way in which wireless research can advance going forward, because frankly, you cannot ignore any one of these three and just move on, right? And every effort that you are seeing here kind of embodies some of these relationships. So I think that's like a common substrate. So currently we have two platforms ready, and ready in the sense of awarded, and they have been going on for a year. One in Salt Lake City and the other one in New York City. And the idea is to provide a diversity of locations, frequencies, and test cases in each of these platforms. And I want to emphasize that we are looking at not just 5G, but beyond 5G. When I say beyond, it's not just in front of, but also inside of, right? So, we have Wi-Fi, narrowband frequencies, and IoT kind of use cases that are not standard specific. We are looking at all of those as well. So again, I'm just going to skip these two slides in the interest of time. So there is Cosmos and Powder. These are the two testbeds that are out there right now. I encourage folks to make a note of these websites. So I'm just going to show it one more time, cosmoslab.org. Look at the very last line. This is in Manhattan. And Powder testbed, powderwireless.net. This is in Salt Lake City. So take a look at these. These slides are going to be available, but please do come to the workshop number 1. In the next session, we can discuss further. I want to kind of talk about some of the challenges that we need to solve, right? This is not just about wireless anymore. One of the things that everybody must be noticing is that we don't talk about RF that much in most of these verticals. We talk about the EPC, the packet core, the network. We talk about data. We talk about how users are using these things, latencies and so forth, but that's not just at the RF level. That's what 5G and what comes next is going to be about, and we need that kind of thinking. And we also need to use these kind of cross-regional collaborations to talk about some of the open problems that we have not solved yet. And these are problems that are been there for a long time. Everybody would love to solve this, but we really haven't made meaningful progress for whatever reasons, right? One of those is spectrum sharing. Spectrum sharing, everybody knows, yes, it'll be good to have, but nobody wants to say how we'll do it, mainly because there's a lot of interesting research problems that need to be solved. And this is a really true cross-regional effort in the sense that spectrum is global. Spectrum allocations are global, globally harmonized in some extent. And this goes beyond your, individual projects, individual principles. This talks about cooperation across regulatory agencies and working with researchers to demonstrate whether true spectrum sharing is possible and at what granularity can we achieve, right? We also need to talk about how to interoperate. And I saw this fantastic example of satellite and 5G. That's a great example. There are more things in there, right? We really don't talk about interoperator mobility that much. Why do we need to deploy multiple cell sites of multiple operators in one location in order to provide service? Why can't we use shared infrastructure, right? Which brings me to that other point about lack of, I would call adequate research in the economic aspects and social aspects of using multi-tenancy and shared infrastructure to support future deployments in wireless. Because the truth is that these deployments are very expensive, and you cannot keep on everybody building their own version of the network. At some point, you know, in the interest of larger economics, the money has to come from somewhere, right? If everybody is investing in building a copy of the network, an exact copy of the network to provide the same service, the money is coming from somewhere, and who is coming from? It's the end customer, right? Our global productivity would become much better if we were to make better use of this economic assets. And therefore, I would call for more collaboration and cooperation in looking at infrastructure models. And this is something that operators, industry, I mean, in the industry and academia and government should all work together, right? And of course, clearly, there is the gap between you know, research and commercialization, and NSF has been funding a lot of activity in this space. And I want to call upon you know, the platforms for our wireless research, whether it's our power program or the programs happening in the EU or in China or in Brazil or in all other countries, or in India also for that matter, to start thinking about using these platforms as a validation step that can help drive the gap between research and commercialization. So with that, I'm happy to take questions later. Thank you.
Thanks, Dr. Nadagopo. Why a local wireless network need a cross-region cooperation? Because we need more knowledge, we need more know-how from a different area. I think this is a target for this session. Okay, so next, the last speaker of this session, it is wireless Vice Director of Department of Wireless and Terminal Technology, China Mobile Research Institute, Mr. Wei Deng. Please, welcome.
Thanks, moderator. I'm Wei Deng, come from China Mobile Research Institute, and it's my honor to share the cooperation between China Mobile 5G trial and EU 5G Drive project. It's one part of the 5G cooperation between EU and China. As we know, EU and China have the long, great cooperation about the telecommunications for the past 20 years. For example, 3G TD-SMA technology and 4G standard. So in 2015, the China and the EU set up the traditional link about 5G. And this project, this cooperation is about two projects. Just MOVE has introduced the EU 5G Drive project. So now I will introduce the China Mobile 5G trial. First, this is about the whole picture about the plan of China Mobile. We can say about the strategy, research, standardization, and so on. And we can say that large-scale trial has played an important role that link the previous work and later operation. And although the 5G commercial license has released in China, and but we think the trial is still necessary for to verify the 5G technology and achieve the operation assurance. The trial is funded by the MIT and led by China Mobile, and we have the 7 participants, including EMBB and CV2S scenarios, and the time duration is 2 years. And China Mobile will construct 5,000 sites in 5 cities. Some more information about the participants. And first is the project is open. And, you can see Ericsson is the formal partner, while Luca was invited to join the trial. And both of them will construct 100 sites separately in Suzhou and Shanghai. And secondly, we can say there are some of the government research institute, for example, TMI and IHMT. It's the government regular about the transportation. To strengthen the 5G collaboration between China and the EU, and the 5G large-scale trial has established the cooperation with the EU 5G trial from November 2018 to June 2020. And about the scope, including conduct a 5G trial on ENBB and V2X, and prepare joint trial specification, and organize joint seminar and workshop, and publish the test results. And the great activities, last year, November, we signed the cooperation agreement, and this year, March, and we have published the joint trial specifications, and including basic performance, massive MIMO, and indoor coverage, and so on. And May this year, hold the second joint meeting and grant the cooperation plan. And also, we have started the joint ENBB trial in Hangzhou from May to June this year. At the first stage, the cooperation focuses mainly on joint trial, so I will introduce some information about the trial. First is about the network. It's NSA or SA. We know NSA is faster than SA, and but SA has more powerful, more capabilities. For example, slicing, MEC. So China Mobile has determined to deploy SA and NSA simultaneously. Firstly, maybe this year or last year, SA for a smartphone and SA for vertical. But maybe later I will involve to SA. SA will service both the individual market and the vertical market. So the joint trial will conduct both NSA and SA. Second is the spectrum, and we know China have get the 100 at 2.0 gigahertz and 100 megahertz at 4.9 gigahertz for 5G trials. So the joint trial will test on these two bands. And the third is about the trial size, and there are the 5 cities: Hangzhou, Suzhou, Wuhan, Guangzhou, and Shanghai. And each city we will have the 100 sites, and we can see we include the dense urban area and suburban. And yes, the SD is very close, very short. About the core network is very interesting topic, and because for NSA, we will base station will connect to the EPC, and for SA base station will connect to the 5GC. And for EPC, we will construct it in distributedly. We will construct it in 5 provincial centers. It's distributed. And for 5GC, because we want to do the 5G to service the vertical, so we want to construct the 5GC concentrated. Yes, we will build, in the trial, we built the 5G in Beijing and Nanjing, only two centers. It's the centralized resource pool. Beijing pool is used for the test functionalities of 5G, and Nanjing pool is used for the end-to-end test and pre-commercial service. It's about this is about the 5G trial plan, and the green is the NSA, and the blue is the SA. We can say that the SA have more test cases. For example, 5G functionality and SPN test. SPN is one of the transportation technology and voice solution and key technologies, maximum slice MEC, and so on. And we plan to finish the NSA test before the end of June, and we want to finish the SA before the end of this year. The last is about the CV2S. We have constructed the citywide CV2S pilot area. In there are 240 intersections and more than 170 square kilometers. And the test will include V2I, V2V, V2N, and V2P, all kinds of the cases. Here is about some of the trial test results of the NSA EMBB. For example, single user throughput. It's nearly reached the theoretical value, and outdoor station coverage for indoor. And we can say, because we use the 2.6 gigahertz, so the performance is very good. And C-plan latency and U-plan latency. You can say the U-plan latency is a little high because we use the 5 millisecond period. So it's not very short. Except the trial, China Mobile has planned to construct 30,000 to 50,000 5G sites before October this year to provide the commercial service maybe in this year. There are 40 cities. And now we have completed about 10,000 sites. And maybe some of the joint tests maybe can be conducted on the new 5G network. Yeah, this is about the next step, and we will focus on joint trial and joint research. And conclusion, the cooperation of CMCC 5G trial and the EU 5G trial is supported by the government and China and the EU Commission. And the cooperation has made significant progress with mutual benefits. More joint activities are under planning, and more joint trial and research will be carried out. And under the spirit of open and collaboration, the joint projects can be the model of the cross-region cooperation. Okay, thank you.
Thanks, Mr. Wei Deng. Actually, not only China-EU project done by CMCC. CMCC actually do a lot of cross-region job, like the GTI group. Hundreds of members also join that group. So CMCC really do a great job. Because of the time limitation, so we have to pass the session of panel discussion, but I still want to give give the question we prepare for the panel discussion. The first one is what is the most necessary job we need to do for the cross-region cooperation, like the standard technology, user keys, or ecosystem? What is the benefit? The second one it is what is the biggest problem you met during the cross-region cooperation, and do we need the 5G event, this platform, to do something to push it forward for some cross-region cooperation? So I think this is prepare for the panel discussion. I think maybe you will find some answer during the speech, and I think we also maybe thinking more in the future. Okay, thank you, and give the applause to the speakers once again. Thank you.
Okay, thank you very much. So we have now earned a coffee break. If you could be back in half an hour, so at 4:15, because we need to start on time, because we need to finish on time. The reminder being we have this wonderful get-together this evening, and the buses are going to leave at 6:30 sharp. So if you're late coming in, we're going to miss that, and we're all going to miss it. So let's try and be on time when we start again at 4:15, please.